Today in this video, we will study how to calculate the absolute extrema, and our objective is to find the critical numbers of the functions algebraically and also calculate the extrema. Now, absolute extrema, we already have discussed this thing in our previous videos, that whenever they ask you about the absolute extrema, it means that you are finding the highest or the lowest point of the graph. Highest or lowest point of the graph are referred highest point. It means that absolute maximum you are finding, and lowest point refers to the absolute minimum of the graph. But you can find the absolute maximum or minimum within the closed interval only. So if you have a graph which is given in the open interval, it means that the ending point, the graph is increasing and increasing and increasing without the bound, and similarly the graph is decreasing and decreasing and decreasing, and you don't know when they will stop. So it means you cannot find out the absolute extrema or absolute extreme points of such graphs. Okay, so similarly, if the graph is given within the last points, initial and the ending points of the graph are open intervals, are not included. Okay, so you cannot find out the absolute extrema of such graphs or such functions also. Absolute extrema algebraically also can be found only in the closed interval. Now let's try to find out one more thing. Let's see this. Here is a graph, and this graph refers to in a closed interval a and b, and there is a point C here and there is a point D here. Now, if someone asks you what is the highest point, find out the highest point of the graph. So you can see that this point refers to the highest point or the peak of the graph. And it is said to be absolute maximum because it is the highest point. But not only this, this is a turning point, right? This is a turning of the graph. And we have seen and we have studied in our previous video at the turning points whether the slope of the tangent line is 0, or if the turning point is like this, the slope of the tangent line at this point is undefined. It means you cannot differentiate this point. So over here, if we look at the graph A right now, so you can see that you have a smooth curve where the slope of the tangent line is a straight horizontal line, which means that at this point the derivative of the equation is 0. And this is also known as the critical number or critical point. So at critical point, you have the relative extrema. And also this is the absolute maximum. Okay, now where is the lowest point? So the lowest point of the graph is here. So this is said to be the absolute minimum. And you can see that absolute maximum or minimum can be found at the end of the graph, at the beginning of the graph, or ending points, end points of the graph, or in the middle of the graph somewhere. And absolute maximum can only be simply a point at the end, which is the ending point of the graph, or it could be a turning point of the graph. Okay, so today's understand that how to find out the absolute these points algebraically, okay, by applying the derivatives rule, by finding the critical numbers. This is what we are going to study in this video. So understand the concept by solving some equation. So here is the equation f of x equals to 9 minus x square, and you have to read this graph within the closed interval -3, which is the starting point, and the 4, which is the ending point. And this big bracket shows that you are talking about the closed interval. Remember, the open intervals are given like that. So if same question is given to you and asked to find out the absolute extrema in this open interval. No need to solve at all. Just write down that there is no absolute extrema. Reason that absolute extrema can be found only within closed intervals. Okay, so now let's come to our own question. F of x equals to 9 minus x square. So the first step is find out the critical numbers. And we have studied to find out the critical numbers, you have to take the derivatives. So derivative of 9 is 0, then this minus, and derivative of x square is 2x. Now set the equation equals to 0 because the critical numbers means that the derivative either is equal to 0 or undefined. Now 9 minus x square is a quadratic equation. It means that you will have a smooth curve. So that's why I set the equation equals to 0 and now solve for x. Divide both sides by -2, so x equals to 0. So what is x equals to 0? At x equals to 0, you will have a critical point. And this critical point could be a relative maximum or relative minimum. Okay, so this relative maximum and relative minimum uh, determination we will find out later on. But right now, focus on the absolute extreme. So now what you have to do, you have to do that now to find out that which points are the highest points. Which points are the highest points, you have to find out the y values. So you have 3 points. The starting point -3, the ending point of the closed interval 4, and the middle of this point 0, because the 0 is somewhere in between the closed interval. So what we are going to do, we are going to find out the y value. So find out f of -3, the initial point, the middle point f of 0, and the last point f of 4. Put it in the original equation to find the y value. So write down 9 minus -3 whole square. So 9 minus 9, it gives you 0. F of 0, so 9 minus 0 square gives you 9. And 9 minus 4 square, that is 16. 16 minus 9 gives us -7. So these are the three y values. Now, which is the highest value of the graph? So the highest value of the graph is 9. Which is at f of 0 equals to 9 is your absolute maximum. Now for absolute minimum, which is the lowest point? Is it -7 or 0? Definitely -7. So -7, f of 4 equals to -7. You will have the absolute minimum. So this is how we find out the absolute maximum and minimum. Now a question arises in the mind that what if this critical point is rather than 0, it's outside this closed interval. Let's suppose it's 5, x equals to 5. Then in that case, while finding the absolute extrema, you will not include this point. The reason that this is outside the closed interval. And your task is to find the absolute extrema within the given interval. So here f of x equals to 2x cubed minus 3x square minus 12x plus 5. So the first thing, in order to find the absolute extrema, we have to take the derivatives to find out the critical numbers. So 3 times 2 gives us 6. 6x from the power subtract 1, you will get the 2 minus multiply. 2 times 3 gives us 6x from the power subtract 1, you will get 1. Minus derivative of 12x is 12 and the derivative of the number is 0. So after finding the derivative, we have to set the equation equals to 0. Okay, now go to the calculator. If you have the scientific calculator, go to the mode 5 and 3. Or if you have another scientific calculator, then you go to the menu, and after the menu find out where the equation is. After that press 2, which refers to the polynomial equation, and after that you again press the 2, which refers to the degree 2. And where is the degree 2? Here is the power 2. Now after that try to find out the factors. Now on the screen this thing appears, right? So over here we already know we have the equation quadratic ax square plus bx plus c. So the coefficient of x square is 6 in our case. Coefficient of x is negative 6 in our case, and the number, constant number, is negative 12. Write with the sign. Write in the calculator, make the equal sign, and you will get the two values of x. X equals to 2 and x equals to negative 1. Now to find out the absolute maximum or absolute minimum, you have the 4 points. Now look at the closed interval. The closed interval is from negative 2 here. The ending point is 4, and this 2 inside the closed interval, and the negative 1 is also inside the closed interval. So you have 4 points where you will find out the y values. F of negative 2, you have f of negative 1, you have f of 2, and you have f of 4. To find out the y values, you have to substitute one by one these values in the original equation. Okay, so first of all, let's see here 2 and then negative 2 whole cube minus 3 to the power 3, then times negative 2 whole square minus 12 times negative 2 plus 5. Write this in the calculator. Write this in the calculator. And let's see what you will get in this case. So if you write this in the calculator, you will get 1. Okay, you will get 1. Now write the negative 1 in the calculator. Write the negative 1 in the calculator the same way, and you will get 12. Now write the 2 in the calculator in the original equation. Okay, substitute the x value with the 2 in the original equation, and you will get negative 15. Now substitute 4 in the original equation, and you will get 37. Now compare all the y values to find out the highest value. So highest or the biggest value among all these y values is 37. So this will give you absolute maximum. So you have an absolute maximum at x equals to 4 and y equals to 37. Now which is the least value, 1, 12 or negative 15? So negative 15 is the lowest or the least value of the y. So this will gives you the absolute minimum value at x equals to 2. So this is how we determine the absolute extrema. Let's try to solve another question. So f of x equals to x cube minus 3x plus 1. So what do we have to do? The first step is we will take the derivative. So x cube, bring the 3 as a coefficient, write the x from the power, subtract 1, we get the 2, minus derivative of 3x is 3. Now the derivative of 3x is 3. Now set the equation equals to 0. Since it is a square function, quadratic function, go again to the mode 5(3) or equation 2 and 2. Write the a value, the coefficient of x square, which is 3. Now the coefficient of x, here there is no x, so you will put the 0. And the constant number is negative 3. Equal sign, then you will get the x values. Okay, so the x values are 1 and negative 1. Now read this thing. Okay, the closed interval. You have negative 3 in the end and 2 at the end. Okay, so negative 1 is somewhere here and positive 1 is also within the closed interval. So you have the 4 values, f of negative 3, f of negative 1, f of positive 1 and f of 2. So one by one substitute these values in the original question. to find out the y values. So negative 3 whole cube minus 3 times negative 3 plus 1. Similarly, negative 1 whole cube minus 3 times negative 1 plus 1. Substitute 1 in the original question, you will get 1 cube minus 3 times 1 plus 1. And now substitute the 2 in the original question, you will have 2 cube minus 3 times 2 plus 1. Now write it in the calculator or do it mentally to get the final answer. So f of negative 3 gives us negative 17. F of negative 1 gives us 3. F of 1 gives us negative 1. And f of 2 gives us 3. You can check yourself also. Maybe I have made some mistake while doing the calculation. So now compare all these values. So the least value is, the smallest value is at negative 7. So f of negative 3 equals to negative 7. You found the absolute minimum. Now the highest value, there are two highest value. Okay, the 3. So you have the two absolute maximum. Okay, so at f of negative 1 and at f of 2. You have the two values, that is absolute maximum. Okay, over here there is a cubic root function. Now first of all, understand few things. That let's see here, it is x to the power of 1 over 3. It can also be written as cubic root of x. Or remember, whenever this radical functions has the n, so this is the nth root, right? So in such kind of the functions, if the n is odd number, so in this case, remember that in this case, you will have a point which comes by solving the function which is inside the radical root. So let's suppose here in our case at x, so make it x equals to 0. So at this point, the function is not differentiable. Means the graph of the function at 0 you will have a conical or a sharp turn. This sharp turn refers to a slope of a tangent line which is a vertical line. So you can say that the slope of the tangent line at this point is undefined, means the function is not differentiable, particularly at this point. Now how to find out this point? Remember that when you take the domain of the function, the domain of the function is all real number because there is nothing in the denominator. Whatever the number you will substitute in place of x, you will get an answer. None of the number makes this function undefined. But when you take the derivative, let's take the derivative. Bring the power in the shoulder over here. From the power, we subtract 1. So you will get negative 2 over 3. Derivative of x is 1, so we are not writing. Now set the equation equals to 0. Look here, you have a negative power, right? You have a negative power, or you can solve it by negative powers also. So make the power positive. So for that reason, you have to change the position of the power. So remember, let's suppose you have x to the power of negative n. So this can also be written as, if you change the position of x from the numerator, you bring it into denominator, the power sign will be changed. The negative n changes into positive n. And there is nothing on the top, so you just write here 1. So this is the property of exponent. So in our case, the 3 is already in the denominator. Bring the numerator in the denominator to make the power equals positive. Make it equals to 0. Now, when you cross multiply, this thing multiply by 0 is 0. And 1 is not equals to 0. So, but in such cases, you take, to find the critical number, you take the denominator and make it equals to 0. So let's see, 3x to the power of 2 by 3 equals to 0. Remember, divide both sides by the 3. So you will have x to the power of 2 by 3 equals to 0. Or you can say x equals to 0. Okay, just to show you that how x equals to 0, multiply both sides with the power of 3 by 2 here, 3 by 2 here. So 0 to the power of 3 by 2 gives you 0, and this will be cancelled out. So remember, if you have x with a power of anything in the power equals to 0. If this structure is given to you, so you can just directly write x equals to 0. So you have at x equals to 0, you have a sharp turn. Means the slope of the tangent line is undefined at this point, and this is also a critical number. But our task is to find out the absolute extrema. So you have a number line -2, 2, and the 0 is in between. So you have the 3 points f of -2, you have f of 0, and you have f of 2. So write these numbers in the original equation to get the y value. So you will have -2 to the power of 1 by 3, 0 to the power of 1 by 3, and 2 to the power of 1 by 3. So when you will write in the calculator -2 to the power of 1 by 3, you will get -1.25. When you will write the 0 to the power of 1 by 3, you will get 0. And on writing the 2 to the power of 1.3, you will get 1.25. Now from here, it's very obvious that -1.25 is the lowest value, so name it as absolute minimum. And 1.25 is the highest value, so it is said to be absolute maximum. Now look at this question. This is a rational function. This is a rational function. Now, there is a difference between this question and the question which we did before this question like this. Now, in this question, what is the domain? The domain is all real numbers. But whenever you have a rational function, the denominator must not be equals to 0, which means that x plus 2 must not be equals to 0. From here, bring the 2 on the other side, so x should not be equals to -2, which means that the domain is all real numbers except -2. Now, what is the difference between this question and the previously solved question? This question, at -2, you have a discontinuity. At -2, you have a discontinuity. Vertical asymptote in this case, or it could be a hole also. And at discontinuity, you couldn't find any absolute extrema. But here at this point, when you got the y prime equals to 1 over 3 x to the power of -2 by 3, so you know that here the domain was all real number. At x equals to 0, you had a sharp turn. And sharp turn refer to a critical point. Discontinuity is not a critical point. Remember, this thing is very important to memorize. Understand the concept that at discontinuity, you don't have any absolute extrema, and discontinuity cannot be a critical point. But in our radical functions, okay, there are the critical points. They says that the derivative is not possible to find out at the particular point. But derivative is undefined doesn't mean you don't have the critical point. Okay, let's start the question. And the first thing is take the derivative. Here it is the quotient rule you are going to apply. The reason is that it is a rational function. So the 2x square refer to the f, and x plus 2 will be your g. The formula you are going to apply is f prime of g minus f of g prime over g square. Okay, so here f prime. So derivative of 2x square is 2 times 2 is 4x. And write down the g as it is, which is x plus 2. Then the formula minus we will write here. And the f is 2x square. And the derivative of g is 1 because derivative of x is 1 and derivative of 2 is 0. Divided by g square. So what is g? X plus 2 and this is whole square. Now solve. Now solve. So 4x times x gives us 4x square plus 4x times 2 gives us 8x minus 2x square times 1 is 2x square divided by x plus 2 whole square. 4x square minus 2x square gives us 2x square plus 8x over x plus 2 whole square. Now make the equation, set the equation equals to 0. Now cross multiply. Again, in this case, when you had the denominator in the derivatives, since the main function domain was all real number, so we set the denominator equal to 0. But in our case, we will not set the denominator equals to 0. The reason is at x equals to -2, we have a vertical asymptote, and at discontinuity we couldn't have any critical points. That's why we will not set the denominator equals to 0. You only set the numerator equals to 0 because the denominator multiplied by 0 gives you 0, and that's it. No need to solve it at all. Okay, so now you will get, when you solve it, so go to the mode 5-3, write down the 2, 8 and 0 in your calculator and you will get x equals to 0 and x equals to -4. Now have a look over here. Here is your number line. On the number line, the starting point is -1. The ending point is 5. Okay, so what critical numbers comes between this closed interval will be taken for our absolute, to calculate our absolute extrema. 0, yes, 0 comes in between, but -4 doesn't comes in between. So we will not consider this point because this is before this is out of the closed interval. Now find it out. Now find out the y values at f of -1, find out f of 0 and find out f of 5 by putting these numbers in the original question. So you write here 2 bracket -1 whole square over -1 plus 2. Write it in the calculator and you will get 2. Now similarly write the 0 in the original question. I am not writing it. You write it down yourself and you will get 0, 0. Now write the 5 in the original question. Let me show you 2 to the 5 to the power of square and then 5 plus 2. Write it in the calculator. Then press SD. You will get 7.14. So which one is the highest point? The largest point is 7.14, which is your absolute maximum. Now the lowest point is 0. So this will gives you absolute minimum. Let's try to solve another question. 5 minus 2x square. So the first step is to take the derivative. Derivative of 5 is 0. 2 times -2 is -4x. Set the equation equals to 0. Divide both sides by -4. So the x equals to 0. Now if you look, this is -3 to 1. This is what the closed interval is. If you look at the closed interval, -3 is the starting point, 1 is the last point, and the 0 comes in between. So what you have to do now? You have to find out the y value at -3, at 0, and at 1 by putting these values in the original equation. So 5 minus 2 times negative 3 whole square, 5 minus 2 times 0 whole square, and 5 minus 2 times 1 whole square. So the first value which we will get, so it's negative 3, so it's negative 18, and you will get negative 13. Over here you will get 5 times 0 is 0, and minus 2, 5 minus 2 gives us 3. So now compare. Negative 13 is the least value, so it will refer to the absolute minimum, and the biggest or the largest value in this closed interval is 5. So at f of 0 equals to 5, you will have your absolute maximum. Let's try one more question. So first thing is take the derivative. So minus x cube, the derivative will be negative 3x square. Minus 2 times 6 will give us 12x. Minus derivative of 9x is 9, and derivative of 3x is 0. Now you set the equation equals to 0. After that, go to the mode 5.3, write the coefficients of x square, x and the number as the a, b and c. So the coefficient of the x square is negative 3, equal sign, coefficient of x is negative 12, equal sign, coefficient, and the constant is negative 9. You will have the two x values, one is negative 1 and one is negative 3. Okay, now have a look over here. So already negative 1 is already in the closed interval, and negative 3 is also the closed interval. So you only have two values. So f of negative 1 and f of negative 3. Put it in the original equation. So negative 1 whole cube minus 6 times negative 1 square minus 9 times negative 1 plus 3, and similarly put negative 3 in the original question, replacing the x by negative 3 in the original question. So negative 3 square minus 9 times negative 3 plus 3. If we write f of negative 3 in the calculator, we will get 3. And if we write this thing in the calculator, we will get 7. Now what is the highest? Highest value is 7, which is at negative 1. So this is your absolute maximum, and 3 is your absolute minimum. Another question, when the power is power 4. So take the derivative f prime x equals to, bring the power as a coefficient 4, x from the power subtract 1, 3. Minus multiply the power with the coefficient. So 8 times 2 is 16. X from the power subtract 1, you get 1. Derivative of 3 is 0. After that, set the equation equals to 0. Now to solve this question, remember you have the 3 power, right? The degree is 3. So go to the mode 5.4, because here you will have ax cube plus bx square plus cx plus d. Or in other calculator, you go to the menu, go to the equation, then go to the polynomial 2, and then press 3 because the degree is 3. Now in the question, you will have here in the screen, you will have 4 places. So the coefficient of x cube is 4. Then the coefficient of x square. Look at this one, there is no x square, so 0. And the coefficient of x is negative 16, and the constant number you don't have, so just write 0. And write in the calculator, you will have the values of the x. So what you will get it? So you will get it as f of x equals to 2, x equals to negative 2, and x equals to 0. Okay, now read the number line. Number line starting point is negative 1 and ending point is 3, the closed interval. Now this 2, yes, the 2 comes in between. Negative 2. So negative 2 is over here, which is outside the closed interval. So we will not take this one. And 0 is somewhere here in between. So we will have 4 values: f of negative 1, f of 0, f of 2 and f of 3. Put it in the calculator one by one. So we will have negative 1 to the power of 4, negative 1 square plus 3. Similarly, 0 to the power of 4 minus 8 times 0 square plus 3. Then 2 to the power of 4 minus 8 times 2 whole square plus 3. And 3 to the power of 4 minus 8 times 3 whole square plus 3. Write it in the calculator to get your final answer. So when you will put negative 1 in the calculator, you will get negative 4. By putting the 0, you will get 3. By putting the 2, you will get negative 13. And by putting the 3, you will get 12. So the highest value is 12, right? So this is your absolute maximum. Now, negative 13 is the smallest number or negative 4? Of course, negative 13. So negative 13 is your absolute minimum value which occurs at x equals to 2. Let's try to solve this question. Now remember, whenever you have any question in which the numerator is a constant number without the x and denominator has some function, it is a rational function, but rather than using the quotient rule, you bring the whole equation on the top, yani write the 8 and write x squared plus 1, 4 and make the power negative. And rather than solving with the quotient rule, use the chain rule to make your life easier. Chain rule says that multiply the power with the coefficient. So 8 times negative 1 gives you negative 8. Write the equation as it is. From the power subtract 1, which gives us negative 2. And then the derivative of the inner function, which is 2x. Now what you have to do, you will write negative 8 times 2x, right? These are the constant things. These are the things which are outside the bracket. Negative 8 times 2, it's negative 16x divided by, it has a negative power, so I am bringing it again in the denominator to make the power positive. Now set the equation equals to 0. Remember, this x squared plus 4 was already in the denominator. So we will not set the equation equals to 0 for the denominator. We will only consider the numerator thing. So negative 16x equals to 0. Divide both sides by negative 16 and we will get x equals to 0. Now 0 is already included in the closed interval. So you have only 2 points, f of 0 and f of 5 to read it. Okay, so now write it in the calculator. So 8 over 0 square plus 4 and 8 over 5 square plus 4. So 8 over 4 gives us 2 and 8 over 25 plus 4 is 29. So 8 over 29 gives us 0.27. Okay, so the highest value is 2. So our absolute maximum is at f of 0 equals to 2 and our absolute minimum is 0.25 which occurs at x equals to 5. Again, now here in the numerator you have a function, in the denominator you have a function. So here you have to use the quotient rule. Refer the numerator as f and denominator as g. So we have a formula f prime g minus fg prime over g square. So take the derivative. F prime derivative of x is 1 and write the g as it is, that is x square plus 1. minus, then we have to write the f as it is, that is x, and then our g prime is 2x because the derivative of x square is 2x. G square x square plus 1 whole square. Now open the brackets using the distributive property. 1 times x square, 1 times 1 is 1, minus x times 2x gives us 2x, divided by x square plus 1 whole square. Now 2x square. X square minus 2x square gives us minus x square plus 1 divided by the denominator as it is. Set the equation equals to 0. We will only take the numerator and make it equals to 0. The reason is that the denominator already is in the question. Now, just to show you, the domain should not be equals to 0. X square plus 1 should not be equals to 0. X square should not be equals to negative 1. And when you take the square root, you will get the I, right? The imaginary number. So that's why I didn't take the denominator at all. Okay, so now what I am going to do, I have to solve it. So I will get the two values, x equals to negative 1 and x equals to positive 1. Now over here, negative 1 is inside the closed interval and 1 is also in the closed interval. So we have f of negative 3, f of negative 1, f of 1 and f of 3. Now write these values in the original question and get the answer. So you will write negative 3 divided by negative 3 whole square plus 1 and you will get negative 0.3. Now write negative 1 over negative 1 whole square plus 1. You will get negative 0.5. Now put the 1 in the calculator. 1 square plus 1. You will get 0.5. And when you will write the 3 in the original equation, you will get 0.3 with a positive sign. Now, of course, it is very obvious that the least point is negative 0.5, which is your absolute minimum, and the highest is 0.5, which will refer to your absolute maximum. So let's try to solve a few more examples. So 3x square over x minus 3, and you have to read it within the interval of 2 till 8. Now again, whenever you look at this question, here there is a function on the top, there is a function in the denominator. So you will use the quotient rule, which says f prime g minus f g prime over g square. Okay, so we will take the derivative first. Now again, remember, at the denominator you have a discontinuity always for a rational number. X minus 3 should not be equals to 0, so x should not be equals to 3. At the 3 you have a discontinuity, and discontinuity cannot be a critical number. Cannot be a critical number, and at this point you will not have any absolute extrema, or at this point you will have no relative extrema. Okay, so f prime of x equals to, now find out the derivative f prime. So derivative of 3x square is 6x. G, write it as it is, that is x minus 3, minus f, write as it is, 3x square, and g prime, derivative of x minus 3 is 1, divided by g square x minus 3 whole square. Open the bracket. So 6x times x, 6x square, minus 6x times 3, it gives us negative 18x, minus 3x square, divided by x minus 3 whole square. Now 6x square minus 3x square gives us 3x square, minus 18x divided by x minus 3 whole square. Set the equation equals to 0. Now the denominator has the discontinuity. So denominator multiplied by 0 is 0 and you will not take this point at all. So set the numerator only equals to 0. Go to the mod 5.3 or equation 2 and 2 and write it in the calculator. Okay, you will get the two values, that is x equals to 6 and x equals to 0. Now write it one by one, put these values in the original equation. So you have this 6 and 0. So here 0 is in the middle of the closed interval and 6 is also in the closed interval. So you will write f of 2, f of 0, f of 6 and f of 8. Put these values in the original equation. So you will have 3 times 2 is square over 2 minus 3. 3 times 0 is square over 0 minus 3. 3 times 6 is square over 6 minus 3. Or 3 times 8 is square over 8 minus 3. One by one write in the calculator. So f of 2 gives us negative 12. F of 0 gives us 0. F of 6 gives us positive 36 and f of 8 gives us 38.4. Okay, so the highest value is 38.4, which is your absolute maximum, and the lowest value is negative 12, which is your absolute minimum. Let's solve one more question. Again, there is a function. It is a rational function. There is something x values in the numerator and also in the denominator. Use the quotient rule. Now, in the rational functions, the denominator should not be equals to 0 because when we solve, so at x equals to negative 1, there will be a discontinuity. And the discontinuity, this is the discontinuity, cannot be a critical number. So while solving it, we will not make the denominator equals to 0. We will not solve at all. Okay, now try to find the derivative. F prime g minus fg prime over g square is our formula. So take the derivative, f prime. So derivative of x square is 2x minus derivative of 2x is 2 and derivative of 1 is 0. And then g, f prime and then g is x plus 1, write as it is, minus f, write as it is, x square minus 2x plus 1. And derivative of g, x plus 1 is 1. Over g square, it means x plus 1 whole square. Now open the brackets. 2x times x gives us 2x square plus 2x times 1 gives us 2x minus 2 times x minus 2x minus 2 times 1 gives us negative 2. Now multiply the whole equation by minus 1. Minus times x square minus x square minus times minus 2x plus 2x and minus plus is minus 1 over x plus 1 whole square. Now solve it. Plus 2x minus 2x cancel. 2x square minus x square gives us x square. Then we have plus 2x. Then minus 2 minus 1 gives us minus 3 over x plus 1 whole square. Set the equation equals to 0. The denominator multiplied by 0 is 0 and it is a discontinuity. So only set the numerator equals to 0. It's a quadratic function. Go to the calculator to factor it. Mod 5.3 and you will get x equals to 1 and x equals to negative 3. Now write one by one in the calculator. But before that, see, your closed interval is 0 and 3 over here. So here it is 0, here it is 3. And 1 comes in between the closed interval. The negative 3 is somewhere out of the closed interval, so we will not take this one. So we will read our function at 0, at 1 and at 3. Replace one by one in our original equation and get the answer. So f of 0 is 1, f of 1 is 0 and f of 3 is 1. How do I find it? By substituting these values in my original question. Now 0 is the least value, so this is my absolute minimum. And the 1, I have f of 0 at 0 and 3. When the x is 0 and x is 3, my y values are same. So I have two absolute maximum. Okay, I hope that this video was clear to you. All your concepts are clear to you. And if you do not understand anything other than the explained questions, you can write in the comment box. Otherwise, rewind the video and look again and again and practice yourself by pausing the video until you master this concept. See you with another concept in another video.